Okay, so second video, section 4.2, verifying trig identities. So again, the directions are just going to say verify the identity. Now, let's get into a little more involved one. For instance, 1 plus cosine x over sine x equals, plus sine x over 1 plus cosine x equals 2 cosecant x. 2 cosecant x. So, at this point, what we have is obviously the left-hand side is more difficult than the right-hand side, so I'm going to work with it. So the first thing I'm going to do is I'm going to get a common denominator because I don't see anything out of the ordinary in there that I can use an identity for right away. So I'm going to get a common denominator. Okay, now when I do that, that is going to cause me to have to multiply this side times 1 plus cosine x to get the common denominator. And that is going to have to cause me to have to multiply this side times sine x. So notice what I have here. I have 1 plus cosine x squared plus sine squared x. There we go. Alright, so now you've got a binomial squared right here. Okay, the top left hand side there. You got a binomial squared. So FOIL it out. So just do your FOIL first, outside, inside, last, just like you normally would in algebra. I know that's weird to be doing it with trig functions, but it's the same process. And if you FOIL it out, you get 1 plus 2 cosine x plus cosine squared x. After you FOIL that out, this is what you're going to get. And then we still have a sine squared x up top. All over our denominator. Don't do anything to the denominator right yet. You'll see why. I always, as a good rule of thumb, unless I see something right away, I'm going to hold off on that denominator until the end, just to make sure. Okay? So the first thing I notice at this point, and hopefully you're beginning to notice these kind of things, is this right here. Cosine squared x plus sine squared x, which is one of our fundamental identities. We know it's 1. Okay? So really, what I have on top is I have 1 plus 1 is 2, so I have, combining my like terms, so I have 2 plus 2 cosine x all over the denominator. Sine x 1 plus cosine x. Now, here's what should jump off the page at you as you're manipulating these. Goal is to simplify this. So, I see that 1 plus cosine x down there, and then I see a 2, that's a 1 plus 1 cosine x down on the bottom, right here. 1 plus 1 cosine x. I see a 2 plus 2 cosine x on top. So I can actually factor out a 2 out of this on top, and look what I have. Okay, this is why I tell you wait on the bottom part here, because notice what I have now. Because I'm multiplying these two together on the top and the bottom, I'm multiplying those two quantities together, I can now cancel out. Now you can't do this if it was addition. If that was 2 plus 1 plus cosine x, or sine x plus 1 plus cosine x, you couldn't do this. But because we have an understood multiplication sign there and there, we can actually cancel these out. And so that leaves me with 2 over sine x. Okay, and hopefully you know what this is, but if you need to rewrite it, I don't care whether or not you show me this step or not, but hopefully I would prefer that you didn't. I would prefer that you went ahead and knew what the answer was, because that's the same thing as 2 times 1 over sine x. I want you to go, and 1 over sine x is the same thing as cosecant x. So this is 2 cosecant x, which is what we're trying to get out of this. See? So we check out. There's our answer. Remember, always keep the final result in mind so you can kind of have an idea of what we're looking for here, what we're trying to prove, these answer themselves. If you get it right or not, it'll equal out, okay? So keep in mind what you're trying to get. Now, I would prefer you go from here to here, okay? I want you to get where you can do that if you can already. All right, so keep that in mind. Now, that's one of the longer ones. Involves a little bit of manipulation, okay? As I said, manipulation is going to be the name of the game. Can you use those identities and manipulate them? Problem solving. The key to problem solving, if you're going to be an engineer, especially, the key to problem solving is being able to take something you have no idea what it all is and to get what you need out of it, okay? You've got to be able to move it around any way possible to get what you need out of it, okay? And this is why you can see where showing your work is going to be very important on test and on comp test and homework and quizzes, especially quizzes and tests. It's going to be very important to show your work, because one little mistake could cost you this problem. Now, you'll know on homework and quizzes whether or not you have it correct, because it'll be verified, right? So you've got to keep that in mind. But sometimes they don't work out, and sometimes you can't get them to work out, and they don't verify. And you can't, no matter what you do, you can't get the sides to equal. So that's possible, but that's not very often. So if you come across one of those, make sure you're showing your work on quizzes and stuff, so that in case you made a mistake, I can give you some partial credit. It's going to be very important with this chapter. All right, last problem, and then get started with section 4.2. All right, so this is the problem. It's cosecant x plus cotangent x equals sine x over 1 minus cosine x. All right, so which side's the easy side? Well, you don't really know. So each side can be as similarly complicated. So what I would do here is I'm going to show you both sides. So let's start with the left-hand side first. And since everything on the right-hand side is in terms of sine and cosine, what I'm going to do is rewrite all of this in terms of sine and cosine. That's the very first thing I'm going to do. Alright, well, notice I have a common denominator here. So this is 1 plus cosine x over sine x. Now, look at how it's flipped a little bit. Okay? Look at how it's flipped a little bit. Alright, so this is where we have to manipulate a little bit, because what we're going to have to do is notice what we're trying to get on the right hand side. We're trying to get sine x on top. So watch what I'm going to do here. Now this is true algebraic manipulation. You may think, Mr. Francis, you're pulling that out of the air. Yes, I am, because I'm doing anything I can think of to get what I need. That's the whole purpose. So I see that I have a sin x on bottom. I need a sin x on top. So what I'm going to do is I'm going to multiply the top of this and the bottom of this by sin x. You said, what? Yes, I need a sin x on top, so I'm going to multiply sin x on top. But when I do that, I also have to multiply sin x on bottom, so I don't change the fraction at all. So at this point, what I have on top is I have sin x times 1 plus cosine x, and on the bottom, I have sine squared x. Now notice, I've got my sin x on top like I want, so I've got to figure out some way to cancel out the 1 plus cosine x. I've got to figure out some way to cancel out 1 plus cosine x. Well, here's my Pythagorean identity relating sine and cosine. And if I take this identity here, and I'm trying to get cosine on the bottom. I've already got sine on the top. I'm trying to get cosine on the bottom. Here's what I'm going to do. I'm going to solve for sine. Sine squared, I should say. So I'm going to solve this for sine squared. Okay? So this is sine x times 1 plus cosine x all over. Now I'm going to make my substitution here. 1 minus cosine squared x. Alright, so here's where it's going to get a little confusing for you if you weren't very good at algebra, at factoring in algebra. This is where, again, just like I did up here by multiplying sine x over sine x, I did that to get what I needed. Same thing here. Look at the bottom of this right here. Look at the bottom of our fraction. Now, that's pretty close to what I need, but notice it's a cosine squared x, and I still have to cancel the 1 plus cosine x off the top, okay? Do you know what this is, what I've circled there? Do you know what that is? Well, maybe you will if I write it like this. In algebra, do you remember this? X squared, this is a formula from algebra. X squared minus y squared equals x plus y times x minus y. Do you remember that? Do you remember what it was called? It was called factoring. Factoring a difference of squares problem. So believe it or not, what I've circled in green up there, we can factor. That's a difference of square problem. So this factors, folks. 1 squared, cosine squared. So that's what makes it a difference of square problem, because it's a 1 squared minus a cosine squared. 1 squared is 1. Cosine squared is cosine squared x. So this is what we have. This is our difference of square. Those are one and the same, okay? So factor this. This factors into 1 plus cosine x 1 minus cosine x. Now this is the ultimate manipulation problem, okay? You're getting some rules of manipulation, some ideas of manipulation here. So your 1 plus cosine is going to cancel because we're multiplying so we can cancel those two out. And so that is going to leave us with sine x over 1 minus cosine x. So we verified using the left-hand side. Now, a lot of people, 99% of you, are going to start with that left-hand side because it's a lot easier to go to take those two functions and change them back to sines and cosines than it is to take sines and cosines and change them the other way. It's just weird like that. But some of you will want to go backwards, will want to go the other way. Now I'm going to show you, I recommend the way we just did. In my opinion, the way we just did is the easy way. Okay? I'm going to show you the other way that your book shows you. Okay? Don't hate me for this. Okay? So, but I'm just trying to let you see different methods. Everything you get to see is just going to help you be able to learn this. So let's suppose you're on test and you choose the right hand side of this. Oh my goodness. What do I'm trying to get cosecant x plus cotangent x. Oh my. I'm going to write that up here so we have it. Cotangent x, excuse me, cosecant x plus cotangent x. This is what we're trying to get out of this. Anybody have an idea on that? Well, this is where you have to get creative again. If you remember, I got sine and cosine really creative. I'm going to have to find some way to get some squareds in there. Why is that? Well, because I've got to figure out some way to be able to use identities. So here's what I'm going to do. I'm going to rationalize the denominator by multiplying by the conjugate. So I'm going to multiply by 1 plus cosine x. So basically, if you think about it, I'm going in reverse order of what we did in the last problem. So if you start on the right side, you're going to go in reverse order. So on top, you get sine x times 1 plus cosine x. And on the bottom, you're going to FOIL these two out. And remember, this is a difference of squares problem. So you're going to get 1 minus cosine squared when you FOIL those two out. All right. Well, using our Pythagorean identity, we can solve for sine squared x and get 1 minus cosine squared. So because I know that, I know I can make some type of substitution in. This is going to be one of those problems, folks, and you're going to run across several of these where you make a substitution just to see if it works. I'll be honest with you. There's a lot of trial and error that goes into verification. You'll make a substitution and then you start looking at your answer and what you're trying to get and you think, man, I shouldn't have done that, and you have to go back and erase. Have a good eraser for this stuff, okay? So we're going to make this substitution just because it's the only thing I can do. There is no other substitution I can make up there. So I'm going to have to make that one. I'm left with no choice but to make this substitution, okay? I'm left with no choice but to make this substitution. All right, so this gives me a sine squared x, which is the same thing as sine x times sine x, just so you know. Why is that important? Because I can cancel out a sine x out of each one of them. So I'm left with 1 plus cosine x over sine x. And this is the point where people get stuck because they look at this and they think, well, there's no more substitutions I can make. There's no more substitutions. Well, and you start thinking, sometimes you'll go around in circles with these problems. So be careful. Don't get frustrated. There is ways to solve some of these. There are ways. So we're not stuck. We just have to manipulate a little bit. So we have a common denominator. So I'm going to split this apart. Like so. Now, 1 over sine x. 1 over sine x is going to be cosecant x. Uh-oh. Look at what we're trying to get. We're getting close. Cosine x over sine x is cotangent x. Well, we verified. And you can check it off your list. So see, sometimes you can go either direction to verify and be able to get the problem. So, number one, what do I need to do to be successful at this? Well, number one, you need to know your identities. I'm going to give them to you on test, but you still need to know them to be able to have an idea of what you can substitute in. Number two, you need to be creative. Creative in manipulating the problem to get what you need, okay? Be creative in manipulating the problem to get what you need. I don't care what way you go about it. Show me your work. As long as you are mathematically correct, I'm going to give you credit for it. There are tons of ways to solve these problems. So you've got to know those identities. You've got to be able to manipulate things, to relate things. Relate sines and cosines with the Pythagorean identity. Relate cotangent and cosecant with that Pythagorean identity. Relate tangent and secant with that Pythagorean identity. You've got to be able to relate things. Be able to write things in terms of sine and cosine. And as your book says, this is what your book says. You want to start with the more complicated side. Try using your basic identities. Try factoring, multiplying, combining fractions, splitting fractions, writing in terms of sine and cosine, all these different things that we've done here today. If that doesn't work, go to the other side and try it and do the same thing to it. Now, with all this, keeping in mind of what you're trying to get, being able to manipulate the problem to get what you need. Okay? I hope this helps. I know that some of it can be confusing. Please ask questions if you have them. This is one of those concepts that practice that makes perfect. I will know those of you that are really practicing the homework, because this quiz definitely shows. And make sure you show work, because partial credit is key in all of this, okay? So y'all have a good day, and I'll see y'all next time.